Today, obviously, we're staying with triangles, and we're going to look at bisectors in triangles. So angle bisectors and segment bisectors. So the first theorem, the perpendicular bisector theorem, states that if a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of that segment. So segment, what did we learn back in chapter 1 about segments? Really? We know about a segment. They're not never ending. Good. So they end, right, Larry? Yeah. A segment is a part of a line with two endpoints. So here's segment EP. If a point is on the perpendicular bisector of that segment, whoops, perpendicular means what? They're going to make 90 degrees. What does it mean to bisect? Cut in half. So I'm going to use the red marker to draw the perpendicular bisector of EP. Perpendicular bisector. All right? If I have a point on the red line, the perpendicular bisector, we'll call it point C, then that point is equidistant to the endpoints. Equidistant, the same distance. So the distance from C to E has to be the same as C to P. If you've got a point on the perpendicular bisector of a segment, then that point is equidistant to the endpoints. So I could put point W down here. Well, W is on the red line, that perpendicular bisector. So the distance from E to W would have to be the same as P to W. Think about it. If the red line is a bisector of this segment, it's going right through the what? Middle. It's right in the middle. So if I pick a point that's right in the middle, wouldn't the distance from that point have to be the same on both ends? Because it's right in the middle, right? Okay, perpendicular bisector theorem. The one below it is this guy's converse. If a point is equidistant from the endpoints of a segment, then I know that that point is sitting on the perpendicular bisector. So I have my segment again, segment EP, and here's point C. The distance from C to E, I'm going to make congruent to the distance from C to P. So since C is equidistant to the endpoints, then it's on the perpendicular bisector. So I can assume that C is sitting right on the perpendicular bisector then. If a point is equidistant to both sides, then it's going to be sitting on the perpendicular bisector of a segment. Okay? Converses of each other. You don't have to remember these theorems. You can always use your stuff from chapter 4. If I look back up at this picture, it says that AB is the perpendicular that's what I'm trying to prove. AP is congruent to AQ, and AB is perpendicular to PQ at B, so I'd get a right angle, right? These two triangles both use AB. So what do you know about those two triangles? They're congruent by what? Good. Triangle ABP would have to be congruent to triangle ABQ by the HL theorem, hypotenuse leg. What does it mean if two triangles are congruent? What? They're exactly the same, right? So wouldn't that mean that BP is the same as QP then? And that's what this is determining. If you have a point that's equidistant to two endpoints, then that point must be sitting on the perpendicular bisector. I got this half to be equal to this half. So if you don't remember this theorem, you can always prove that the triangles are congruent, and then just use your corresponding parts and go from there. All right? Okay, those are your bisectors of segments. Flip it over, and we have bisectors of angles. So theorem 5.4, the angle bisector theorem. If a point is on the bisector of an angle, then it is equidistant from the sides of that angle. Here's angle ECP. And we have an angle bisector. Call it CW. What does it mean to bisect an angle? So then angle ECW would have to be congruent to angle PCW. Right? That's my angle bisector there. If I have a point, I don't know, point A, that is on the angle bisector, then the distance from that point to each side of the angle has to be the same. The distance from A to the bottom would have to be the same as A to the left side of the angle. Any point on the angle bisector. Point W, the distance from W to the left side of the angle has to be the same as W to the bottom. Think about it. CW was a what? A bisector, which means it's passing right through the middle. So if I pick a point that's right in the middle of the angle, wouldn't it have to be the same distance from both ends? Yeah, it's right in the middle. Okay, that's your angle bisector theorem. The one below it is its converse. If a point in the interior of an angle is equidistant from both sides, then I know it's sitting on the angle bisector. So angle AGC, and we'll put point E here in the middle, interior of it. It's going to be equidistant to both sides. We'll call that W and this one R. Okay, so if I have a point inside of an angle that's equidistant to both sides of the angle, then it's on the angle bisector. So if E is the same distance from the left side of the angle as it is from the right side, it must be directly in the middle of my angle. Therefore, GE is going to be an angle bisector. So if you know that the point is on equal, or is right in the middle, it's equal on both sides, then you can draw in an angle bisector. If I had a different point, I don't know, F, and I knew that the distance from F to A was the same as F to C, then F must be on the angle bisector because it's right in the middle if it's the same distance on both sides. Okay? They're converses of each other, so they mean the same thing. It just depends on what you're given. We're going to take these four theorems and we're going to apply them now. There are no theorems or no proofs on your worksheet today, so I didn't want to take the time to go through them. So flip your paper over one more time. We're going to apply all of them. So at the top there, we have to find the value of x and then the length of two segments there in the diagram. Looking at our four theorems, we had a perpendicular bisector theorem and an angle bisector theorem. When I look at this picture, would I go with the perpendicular bisector of a segment or an angle bisector? What's my picture showing me? Angle bisector, right up here, angle C is getting bisected. So the angle bisector theorem says that if you have a point, F, on the angle bisector, then the distance from F to both sides has to be the what? The same, equal, right. So then FB would have to be equal to FD. That's your angle bisector theorem. So what are we going to do to find the value of x? Set them equal to each other. I'm going to subtract 2x over to the right and add 37 to the left. So 42 would equal 5x. You agree with my math? It is? All right. You could write it any of these three ways. 8.4 is a nice decimal, so if you like that, then you can use that. So there would be your x value, decimal, mixed number, and improper. Then it says to find the length of FB. Well, how are we going to find the length of FB? Substitute it back in. 2 times 8.4 would give me 16.8 plus 5. So FB would be 21.8. FD should also give me that, but double check to make sure you solved it correctly. 7 times 8.4 would be 58.8 minus 37. So it would also give me 21.8. That's if you're using your angle bisector theorem. But if you can't remember that, then think back of all the stuff you just tested on Wednesday. There's two triangles there. They have a pair of angles congruent up at C. If this one on the outside is 90, the one adjacent to it has to be what? Same with this one, right? So those two angles would be congruent. And both triangles use segment CF. So we could say that triangle BCF is congruent to triangle DCF by which one of our 5 ways? Angle, angle, side. If triangles are congruent, then they're exactly the same, right? So wouldn't that also conclude that BF is congruent to DF by CPCTC then? So then from that you can set up your equation. So the blue ink is explaining angle bisector. Here in red, if you can't remember the angle bisector, then just prove your triangles are congruent and use your corresponding parts from there. Cool. Next one. Using this information, CD is the perpendicular bisector of segment AB. So the vertical line is creating a right angle with the horizontal one, and it's cutting it in half. We have that already marked for us. Perpendicular bisector, so we're going to be looking at the perpendicular bisector theorem. That was the very first one. If I have a point, C, on the perpendicular bisector, it's right in the middle, so the distance from C to each endpoint would have to be what? Equal. So what's the length of AC going to be? 5. Because C is on the perpendicular bisector. It's right in the middle. So the distance to the ends has to be equal. D is also on the red perpendicular bisector. So D's right in the middle. So the distance from D to A should be equal to the distance from D to B. Therefore, DB is going to equal 6. Questions on those ones? What kind of triangles do we get here? Like the bottom ADB? Isosceles, and ACB would be isosceles as well, right? Yeah, because there's 2 equal sides. All right. 3. According to our diagram, they want to know how far point K is from EH and ED. So the distance from the point to the line. Well, the distance between 2 objects, or the shortest distance between 2 objects, is always a what? Come on. Never heard that? The distance between 2 objects is always a... If I want to walk to the back of the room, would it be quicker to go around or just go... There you go, a straight line. The distance between 2 things is always a straight line, right? Oh. I wouldn't measure the distance from me to the lamp to go around Wells and Sarah, or I would just go straight there, right? Okay, so the distance between a point and a line, shortest distance, is a straight line. Here's point K. Here's EH. So the distance from point K to EH has to be a straight line. So how far is it from K to EH? 10. Here's ED. So the distance from K to point K to ED would have to be what? 10, because they're marked congruent to each other. You see your congruent tick marks? Don't forget what those things mean. K is 10 away from each side of the angle, right? So if it's the same distance to the top of the angle as it is to the bottom of the angle, is K going to be towards the bottom of the angle, towards the top of the angle, or right in the middle? Okay, that makes sense. If K is right in the middle, then K must be sitting on the angle's what? Bisector. If it's right in the middle, then it's sitting on a bisector, because bisect means to cut in half. So what can we conclude about ray EK? That it's a bisector. It's an angle bisector. because K is sitting on it, and you guys just told me K's got to be on a bisector, so then EK is a bisector. Since K is right in the middle, it sits on a bisector, and we're bisecting an angle here. Part C, we have to find the value of x. X is representing angles DEK and HEK. Well, if EK is an angle bisector, what would I know about angles DEK and HEK? They're congruent. Good, Sierra. I'm cutting an angle in half, so the two halves have to be equal. So set your x expressions equal to each other. X plus 20 equals 2x. What do you get for x? 20. And then our last one says, find the measure of angle DEH. That's the yellow one I have highlighted. Using substitution, if x equals 20, what's 2 times 20? And 20 plus 20 would be, so my angle DEH is equal to 80. Right, 20 or 40 plus 40. Cool. If it's in the middle, it's on a bisector, whether it's an angle bisector or a segment bisector. Middle bisect. Try the next two on your own, 4 and 5. Which segment is getting cut in half? CD or AB? AB is getting cut in half because this is 8 AN and then NB is 8. So CD, this horizontal segment here in red, that's the perpendicular bisector. He's the one that's getting or doing the cutting in half here. If I want to find the length of BD, well, D is on my perpendicular bisector. So the distance from D to the end point has to be the same as D to the other end point. So how long is BD? 16. Good. You guys all got that? Sweet. C is equidistant from what two things? A and B. It's the same distance from point A as it is from point B. The length AC and BC would be equal, but we're saying they're equidistant from those 2 points, A and B. All right, number 6, 7, and 8. Go ahead and do those three. You would be using the angle bisector theorem, which says a point on the angle bisector is equidistant to the sides of the angle. But if you don't remember that, we spent, I don't know, a good 4 weeks proving that two triangles are congruent. So if I look at this picture, the angles at B are equal. A and C would have to be equal because they're both right angles. And both triangles use segment BG. So triangle ABG would have to be congruent to triangle CBG by what? Angle side. Angle side. If triangles are congruent, then all of their corresponding parts are, right? Okay, so AB would be the same as which side on my other triangle? BC. Well, that's not going to help me find X because I don't have it there. AG would have to be the same as CG. These are the two X's then you're going to set equal because those corresponding parts have to be equal. 2x minus 4 equals 4x minus 16. What did you guys get for your X value? No, you don't have to mark it all. Find the length of CG. So now I'm going to plug this in. 4 times, is it 8? It's not 8. It should be 6. Come on, guys. 6. If it's 6, 4 times 6 is 24. 24 minus 16?
8.
That's 8. CG would be 8. The last one, you have to find the perimeter of quad ABCG. How do we find the perimeter of any polygon? Add up all the sides. Well, we just figured out that CG is 8, which we marked congruent to AG, so we know that's 8. AB, well, if X is 6, 3 times 6 minus 2 is 16. And we already marked that equal to BC, so we need to add 16, 16, well, and 16 again. So then our perimeter of our figure would be 48. Hannah, does that make a little more sense when I use the congruent triangles? Okay, then do that. Questions? All right.